Welcome to AutoSens. My name is Carl Anthony, and we're here at the Michigan Science Center in Detroit. We're speaking today with Mrinal Sood, who is the Director of Technical Marketing at AEye. And Mrinal, thank you for joining us today.
Thanks, Carl. Thanks for having me.
So, Director of Technical Marketing, tell us what that's about. Tell us about your role and what you do each day.
I'm basically the bridge between our engineering teams and our sales team to be able to create the right kind of content and translate the latest and greatest features and developments for the customers and create collateral around it so it can be communicated in a simple manner to the customers.
Yeah, and that's such an important role. And so when it comes to your customers, when it comes to collaborations, you have a very important one right now with Continental, but it's not your average collaboration. So tell us about your partnership with Continental and why maybe it's different than the average typical collaboration in automotive.
Yeah, so Continental is a leading provider of ADAS solutions, and they have been for about 25 years. They've sold lots of cameras and radars and ultrasonic sensors to, I think, more than 60 different makes and models globally. Yeah. And they, I think, had a recent milestone last year where they shipped their 100 millionth radar module to the OEMs. And in terms of the LiDAR market, they were one of the pioneers initially in the 2007 stage when they launched the single-point LiDAR for enhanced emergency braking. Sure. And so far they've shipped over 20 million of those units, and later this year they are launching their short-range flash LiDAR product for cocooning the vehicle for automating lane changes. Right. But throughout this journey they kind of learned that they had a perception deficit in highway high-speed driving. And in that process they learned that as you're deploying these systems to be able to coexist with human drivers on the highways, you have to operate at 120, 130 kilometers per hour. And they knew this perception deficit, and they knew that you have to detect and classify objects at 300 meters. You have to be able to look at obstacles at 200 meters, like small obstacles, like bricks and tires and things like that. And they did an exhaustive search for almost 2 years to look for the right company, right architecture to partner with. And in 2020, they chose to partner with AEye. And that partnership is quite different from the other LiDAR vendors that have partnered with Tier 1s, because most LiDAR vendors end up creating a box and then they go to the Tier 1 to say, hey, manufacture this box. Whereas what we've done is taken a different approach. We have a licensing model. We act with Continental as one collaborative team. We innovate on the lasers, the optics, the photodetectors, the algorithms, and that's sort of the core of our Foresight platform. Right. And we license that out to Continental, and they use their industrialization expertise to productize, to manufacture, to take care of the liability, the warranty, the post-production support. Right. And that allows us to stay on the cutting edge of the innovation. Right. So it's quite different from the other approaches we've seen in the LiDAR market. Sure,
it really is, and it is a tremendous partnership and one that you're famous for across the industry. Mrinal, during your roundtable discussion today, you shared a number of thought leadership, of course, and addressing a number of challenges. You will probably say it more succinctly than I will, but the challenge of higher levels of autonomy and speed, and level 3 systems and things like this. So walk us through your roundtable discussion and what did you cover there?
Yeah, our focus was to shine the light on how these systems that are the LiDAR systems that are being deployed for L3 and beyond are going to have to be able to adapt in terms of their performance to adapt to the different ODDs. Yes. If you think about the different domains, these vehicles so far are geofenced and they're limited, but as the L3 systems get deployed, the OEMs will start to allow more complex maneuvers in different ODDs, including parking lots, including city streets and the highways. And each domain has quite a different requirement from your perception stack, and thus a different requirement in terms of range, resolution, field of view, and frame rate from your LiDAR sensor. Right. And what we see is if you go in the parking lots, you're going maybe 30 kilometers per hour, and you're worried more about sudden appearances of humans and pedestrians and shopping carts and curbs and things like that.
Sure.
Whereas in the city streets, you're worried more about, you're observing more of the lanes, left turn lanes, right turn lanes, intersections. But as soon as you go to the highway and you accelerate, you go 100 kilometers, 120, 130 kilometers per hour, now you're really honed in on directly what's ahead of you in your ego lane. Right. And you do care about the adjacent lanes for lane occupancy, of course, but most importantly for collision relevance, you're worried about directly what's ahead, including things that are on the road debris, small obstacles, bricks and tires.
Yes.
So what we created was a fundamentally different architecture. It's a software-defined LiDAR architecture where we allow programming each laser shot that goes into the LiDAR. And we sit with customers, we take a customer-centric approach, and we have them define unique performance modes that solve their very particular needs.
Right.
And this way we allocate the right amount of range, resolution, frame rate, and field of view depending on the ODD that they want to drive in. And by doing this, taking this approach, we always make sure that the data that we're feeding into the perception system is always going to allow them to have enough time to react to make that decision for path planning, for steering, for braking, acceleration, without worrying about lack of the proper data.
Right.
And having this reaction time or allowing this reaction time allows them to deploy L3 systems quicker and safer.
Right, and that reaction time is critical at higher speeds, I would imagine.
Absolutely.
So you also have another announcement that you made related to vehicle architectures, exciting news. So walk us through that latest news there from AEye.
Yeah, the press release went out yesterday and we had a pretty exciting announcement. So all the different vehicles that exist in the world today, you have sedans, you have SUVs, you have crossovers, minivans, large vans, you have different types of trucks from class 2 to class 8 semi-trucks. Every single vehicle type dictates a different form factor, different packaging requirement, different installation location on these vehicles. You could have sensors installed in the grille, on the bumper, on the roof, behind the windshield. And historically what's happened is LiDAR companies had to recreate products and redefine architectures from the ground up. So both the insides and the outsides of these products would be different. But with our software-defined architecture and with the Foresight platform, what we've allowed our partners like Continental to do is they can take the core of it, keep the internals the same, and change the externals to be more adaptive to the vehicle requirements. Ultimately, it's up to the design teams of these vehicles what the design should look like. Right. Because if the car is not appealing to the consumers, they're not going to buy it.
That's true.
And so we see these types of requirements from OEMs globally, different ways that the product needs to look, different locations where they need to be installed. And a lot of times the LiDAR companies had to recreate products and it was a heavy lift effort.
Yeah.
But by using the Foresight platform, we allow the performance to be reconfigured through software. Right. So even if your outsides of the product may look different to adapt for the different vehicle types, the insides are quite similar.
Yeah.
And you can allocate the range, the resolution, the field of view, and the frame rate with a click of a button, in a way, right? You're configuring it through software. And this approach allows us to be flexible and be able to adapt to all the different vehicles that exist globally. And yesterday's announcement was we revealed a reference vehicle, what we think is sort of the future, by showing a Foresight product that was designed around the grille and the bumper, and then another one on the roof using the same technology inside. And we were able to reconfigure the software or the performance through software. And this approach would not have worked had we not thought about the software-defined architecture from the beginning.
Right.
And now we're seeing a significant shift in the OEM's thinking. Everybody is moving towards the software-defined vehicle, and they want to be able to add performance and add features over time, over the air, and we're ready for that. This is exactly what our thinking was many years ago when we started working on this architecture. So I think that we're going to see lots of products being deployed through our partner Continental based on the Foresight platform that meets all of these different design requirements for packaging into grills or bumpers or the windshield or the roof.
Right. So let me pick your brain and get your thought leadership here for just a second, because AI is at the front of the industry, at the front of innovation, and you're right, software-defined cars are coming. I mean, that is where everything is pointing. That was a huge topic of discussion here at AutoSens, just a big topic in the automotive industry. So what are your thoughts just in general on software-defined cars? What's your perspective there?
I think Tesla changed the game. I think they sort of saw the fragmented approach that was being taken in vehicle design for many years, and they looked at all the electronics that could be combined and centralized in ECU that controlled a lot of the different functions, whether it was your cabin functions, lighting functions, ADAS features, and that effort paid off, and today we're seeing the success from Tesla, and now a lot of the other OEMs, Volkswagen included, they're moving towards the software-defined vehicle. So this is a trend that's it's started, it's here to stay, and all vehicles in the future will become software-defined.
Right. Last thing I want to pick your brain on, AI active in automotive, but also active in trucking as well. You have leadership in a number of other industries. Just give us your thoughts there as we wrap up. Trucking, rail, ITS, share any other thought leadership there and what AI is doing in those industries.
Yeah, Foresight platform that we designed, it's with the partner Continental, we are able to tackle both the passenger car market and the trucking market.
Right.
But for the non-automotive market, your sensing requirements are a little bit different.
Yeah.
And you let's say on a rail, you're looking at track clearance, you're looking at intersection crossings where people or vehicles may be stopped on the tracks.
Of course, yeah.
And in those areas, you have to sometimes see out to 400, 500, 600 meters, or even 700, 800 meters. And we can do that all through software by reallocating range, resolution, field of view, and frame rate for each use case. So the platform that we designed was not designed just for one specific market.
Yeah.
It was designed to put the users in control of the performance that they could change through software and tackle any application where LiDAR is needed.
And that is groundbreaking for sure. Mrinal, I want to thank you for your time today from all of us at AutoSens. I want to wish you safe travels home and wish you and the AI team the best of luck going forward. Thank you for your expertise today.
Thank you so much, Carl.
To hear from more experts like Mrinal, visit our AutoSens YouTube channel and subscribe, and visit our website, auto-sense.com. That's auto-sense.com.